This is our last math lab assignment. This one is this lesson is extremely easy. We've done the hard work on it already. So what we have done so far is factor, and what we're doing today is actually going on and solving the quadratic. So, for instance, this one's already factored, and how I know it's already factored is it's got parentheses in it. Okay, so if there's parentheses, that means it's already factored. So as long as it's factored, as long as it's set equal to 0, I can solve it. And here's how you solve it. All you do is take each factor and set both of them equal to 0. So I'm going to do both factors and set them both equal to 0. Hannah and Lauren, close your computers, take notes. Leland, take notes. Close your computer. Jack, close your computer. So I'm going to take each factor and set it equal to 0. Then I'm going to divide, like on this first one, to solve it, all I would have to do is divide by 3. So one of my solutions is 0. The next one I would add 5. And so my other solution is positive 5. So the two answers are 0 and 5. Now, remember, the solutions to a quadratic are where the curve crosses the x-axis. So if we were really writing these as x-intercepts, which in math lab sometimes they say write them as intercepts. If they're intercepts, it would be 0, 0, and 5, 0. If they just ask for the solutions, you can write it like this. But if they ask for the x-intercepts, you write those two solutions as two separate points.
How many problems are on this math?
15. Okay. So pretty easy, right? If it's already factored. Okay. Everybody ready for the next one?
Yeah.
All right. So again, this is already factored because I have parentheses. So I'm going to set each factor equal to 0. So what's in the two parentheses gets set equal to 0. Then on this one, I would add 5. And then I would divide by 3. And that turns out to be a decimal, so I would leave it as a fraction. 5 over 3. Does 5 over 3 reduce?
No.
No, so we'll just leave it. This one I would add 3 to both. And then divide by 9. That one is 3/9. Does that one reduce?
Yeah.
Yeah, to 1/3. So the solutions are 5 over 3 and 1 over 3. Again, if they want you to write them as the x-intercepts, you would put 5 over 3 0 and 1 over 3 0. Okay. So some questions they ask you to write them like that. Some questions they ask you to write them like that. So we did the hard work on this last week because the factoring was the hard part. This is not the hard part. There are some today that they are not factored, so I want to show you a couple of those. Like this one's not factored. Okay. Do we need to multiply A times C and do factor by grouping on this one?
No.
Why not?
Because there's no uneven that it goes in. There's no number on the outside.
There's no number in front of x squared. Okay, that's our hint. If there's a number out here, then we've got to do multiply A times C.
Well, once it goes in there,
Okay.
we just factor it in.
So we just factor this one. So we want factors of what? 30. And the sum has to be negative 11. Okay? So what will multiply together to be 30 but add to be negative 11? Brian, I would prefer you pay attention and write down the answer, the work. What's going to multiply together to be 30 and add to be 11, negative 11?
5 and negative 6.
Okay, 5 plus negative 6, though, is negative 1.
So can you do both negative?
Both of them negative. Yeah. So negative 5 times negative 6 is positive 30. And negative 5 plus negative 6 is negative 11.
Well,
So what would our two factors be then?
x minus 5
X minus 5
and x plus
minus 6, because they're both negative there.
Yeah.
So then we solve it. This is the step we're doing, further today. Last week we would have been done because we would have just factored it. But to solve it, we just go one step further and set both of them equal to 0. And that's pretty easy. So the solutions are 5 and 6. If you're writing them as points, it would be 5, 0, and 6, 0. That's where that curve crosses the x-axis, at those 2 points. It's a real skinny curve because it's crossing right beside each other twice. It's got to go down and back up. All right, last one's the hardest one, so let's pay attention to this one for sure.
Subtract 20 from both of the 20.
Okay. So why do we need to subtract 20?
Set it equal to 0.
It's got to be equal to 0 first. So we're going to start by moving the 20 over. So when the 20 came across the equal sign, it became negative. Okay, so that's the first thing we need to do. Now, I personally would rather that not be a 12, right? Because I know if I have that number in front of x squared, I'm going to have to do a times c, right? So the first thing I'm going to try to do is get rid of that 12 if I can. Could I divide everything by 12? Will that work? Okay, it won't divide by 12. But 12 times 20 is pretty big, right? So if I could make it smaller, that would be helpful. So since I can't divide by 12, let's see if I can divide by something else to make it smaller. 4. 4 will work. I don't know why that keeps coming up. Okay, so divide by 4. So we've got a 4 out in front. And this becomes 3x squared. This becomes 14x. And that becomes negative 5. All right, now I am still going to have to multiply a times c, right? But it's not as big as 12 times 20. 3 times 5 is a lot better than 12 times 20. Okay? So the first thing we're going to have to do is multiply a times c. This is what we did last week. By the way, on your homework, there's only one of these. And I think it's number 9. Okay? So I'm pretty sure if you want to put number 9, I'm pretty sure that's what this one is. Alright. All the rest of them are real easy ones. Alright, so a times c here, 3 times negative 5 is negative 15. Right? This is A, B, through C. So I want factors of the negative 15. Remember, when we have to do a times c, we've got to do the negative 15, not the c. And the sum is going to be 14.
Whoa. Negative 5 times 3 is not 14. What is 14? Oh.
Okay? You may think of anything?
No.
One.
Negative 1 times.
Oh, negative 1 times 15.
Negative 1 times 15. Yep. Negative 1 plus 15 is 14. Yep, that works. Now, remember, we can't put those in parentheses. We have to do that factor by grouping thing, which is not fun, but we're just going to have to do it. So remember, we rewrite this one, but we don't put this b in. Instead, we put these two things in place of the b. So we've got 3x squared, and instead of that b, we're going to put these two that add up to be 14. So negative 1x plus 15x, and then go ahead and put the negative 5.
Equals 0.
Yeah, I'll come back and put that in a minute once we finally figure out what our factors are. Okay? So now remember, we group the first two and we group the last two. What's going to go into 3x squared and 1x? 1x. Yep, 1x goes into both of those. So what we divide by comes out front. And what's left here? 3x. Because remember, this is a squared and this is a 1, so there's 1x left. What about this last one? Just a 1, right? 1x divided by 1x is a 1. Okay, what would go into 15x and 5? 5.
It's negative 5 though.
No, because the first one's positive, so we won't mess with it. As long as the first one's positive, we're okay. So it's a positive 5 that comes out. 15 divided by 5 is 3, and we still have an x left. 5 divided by 5 is 1. Remember, we want our two parentheses to be the same. That means we did everything right. Okay? So our parentheses that's the same comes out front, and whatever's left goes in the second parentheses. Whatever's left goes in. Whatever's left goes in the second parentheses. Okay, so now this thing is factored. Okay, we've got that thing factored now. Now we can finally solve it since it's factored. The solving's not hard. That's not the hard part. It's factoring is easy. Okay, so set all three of these need to be set equal to 0. So 4 equals 0, 3x minus 1 equals 0, and 1x plus 5 equals 0.
But 4 isn't equal to 0.
That's true. So that's not even a solution. Okay?
Is this a no solution?
No, we can solve the other two. We just can't solve that first one.
Yeah.
So we're good. So we can add 1. Divide by 3. Hey guys, 1 divided by 3 is not 3. It's 1/3. Okay? 3 divided by 1 is 3, but not 1 divided by 3. Okay, then on the second one, subtract 5. So x is negative 5. You can divide by 1 if you want to.
We still get 5.
You're still going to get negative 5. So the solutions for that one are 1/3 and negative 5. What if they say write them as x-intercepts?
1/3 x 0.
Negative 5, 0.
Negative 5, 0. So just pay attention to what they ask you to write them as. Either solutions or x-intercepts. I think towards the end they start asking you to write them like this. All right. Okay. That's the only real long one, number 9. The rest of them are short like the other ones. Okay? All right, guys. This is due Wednesday at the beginning of class. Wednesday at the beginning.